Hello everyone, good evening. Today in this lecture we will be studying something called aldol condensation. So basically, aldol condensation is a part of carbonyl compound in the organic chemistry. So in this lecture what we will do is we will study the aldol condensation in great details, and then we will see few questions that has appeared in previous year questions. Okay? So first of all, what we are going to study over here? First, we are studying about various types of aldol condensation. Second, then we will go on to the mechanisms. Firstly, in basic, medium, then in acidic medium, then we will study something called intramolecular aldol, and at the end we will do some PYQs of JEE mains. So I will just request you all to sit tight to understand the concept. We will go really slow for the first time, and it will be beneficial for you if you have already done it, because it will be a revision for you. So just keep your pen and paper ready, make some notes, the thing that you found useful, keep the running notes going, and try to understand it. Okay, so without further ado, let's start the classes. I hope we all are all set up. So first of all, what is aldol condensation and what are the requirements? So basically, aldol condensation takes place on carbonyl compound. Carbonyl compounds. Carbonyl compounds can be of two types. We know it can be aldehydes and ketones. Right? So aldol condensation can take place in any of the carbonyl compound. Are there some conditions? Of course. Some first conditions that should be there in aldol condensation, that this carbonyl compound should have an enolizable alpha hydrogen. That means what? The carbonyl compound should have an alpha hydrogen that can form an enol. Okay. But for the sake of simplicity, you can remember that if a compound has an alpha hydrogen, then it undergoes then it undergoes aldol condensation. Why enolizable? There are some examples which we will do, some exceptions are there which we will do at later part in some other video where there are alpha hydrogen but still the molecule is not going aldol condensation. But those are exception, rarely have ever come in the exam. So if the molecule, that is the carbonyl compound, has the enolizable alpha hydrogen, then it will undergo aldol condensation. Clear? Now the next thing is, what are the reagent? What are the reagents that are used? So for normal aldol condensation, what we need is a source of dilute OH minus. Means a dilute base is required. That can be dilute NaOH, or dilute KOH. Any OH minus can be used as a reagent for aldol condensation. So these are the first two things that we need to know. If the compound is a carbonyl compound, it generally undergoes aldol condensation, provided it has an alpha hydrogen, and the reagent that is used is a dilute OH minus. Okay, now let's quickly move on to the reaction. Let's say we have something like this: CH3, C double bond O, H. Right? Now see, in this molecule what we have this is my functional group, that is my aldehyde group. This is the carbon that is attached to the functional group. So this is my alpha carbon. And how many alpha hydrogens are there? There are 3 alpha hydrogens. So this molecule is filling up the criteria to do the aldol condensation because it has 3 alpha hydrogens. So this molecule will undergo aldol condensation. This is basically acetaldehyde molecule. Now if we see this one, this molecule, let's say this is my functional group. This hydrogen is directly attached to the functional group. There are no alpha carbon over here. So this hydrogen is not an alpha hydrogen. This is not alpha hydrogen. So this molecule, that is formaldehyde molecule, will not undergo aldol condensation. Let's take another molecule. This is a benzaldehyde molecule. Now see this. Now just pause the video and just try to think whether this molecule will undergo aldol condensation or not. So first of all, what we need to know, this is my functional group. So the carbon that is attached to the functional group is my alpha carbon. So this carbon is alpha carbon. Are there any hydrogen attached to it? Of course not. There is alpha carbon, but there is no alpha hydrogen over here. So again, benzaldehyde molecule will not undergo aldol condensation because there are no alpha hydrogen in a benzaldehyde molecule, right? If you draw the structure very elaborately of this molecule, it looks something like this. Put the double bonds. And it is something like this. Now see, this carbon is my alpha carbon. All the 4 bonds are filled up. This is forming double bond with this carbon. So 2 bonds, 2 and 2. So 4 bonds are there. So there is no alpha hydrogen. So again, this molecule will also not undergo any aldol condensation. We are clear about this. So if the molecule has an alpha hydrogen, generally it will undergo aldol condensation. If it does not have, it won't undergo aldol condensation. It will undergo some any other type of reaction maybe, but that we will discuss later. Now take the molecule. We have acetaldehyde molecule, let's say CH3, C double bond O and H. Now what will happen when we add OH minus? What will happen when we add OH minus? Aldol condensation will take place. We will have something like this. Okay, we will have a product something like this. This is a aldol condensation product. Now if we do the normal nomenclature, what is this? This is an aldehyde group and the OH is there, right? So we know that the first priority comes to the aldehyde. So we start numbering from this 1, 2, 3, 4. So what will be the name? 3 hydroxy, 3 hydroxy, 4 is there. So butanal. This is my product for the aldol condensation. How it is taking place, the mechanism, we will do it. But see, now every molecule will give a different product, but we give a general name to this. Okay. Now see, this is my main functional group. If you see, this is my main functional group. That is my aldehyde group. Right. This is my alpha carbon, and this one is my beta carbon. In the beta, there is an OH there. So generally, we denote it by beta hydroxy carbonyl compound. Clear? So this molecule, in general term, we call it beta hydroxy carbonyl compound. Clear? Okay. Now we go on to the mechanism of the reaction. How we are getting this product. So first step, we have an acetaldehyde molecule. In presence of OH, what will happen? OH will act as a base. OH will act as a base, and it will abstract a alpha hydrogen. So now there are 3 alpha hydrogen. So OH can abstract any of the alpha hydrogen. So we will have CH2 minus, C double bond O, and H. Clear? Now see, this negative charge that is there, it is resonance stabilized. So it can push back over here, it will go over there. So we have a resonating structure. CH2 double bond C, O minus, H. So basically this carbon ion that is formed is stable because it has a resonance stabilization. In GOC we have studied when something is stabilized by resonance, it adds some kind of stability to it. Now see, this is the first part that is done. Now in the reaction medium, there is never a single molecule. For example, let's say I have taken 1 mole of acetaldehyde molecule. So 1 mole means Avogadro number of molecules are there. 6.023 into 10 to the power 23 numbers of molecules are there. So there will be unreacted acetaldehyde molecules also. Right? There will be unreacted acetaldehyde molecules also. So now what will happen? The thing that will happen over here is then this will push back. The O minus will push back over here. Then this bond will attack the unreacted carbonyl compound and we will have something like this. So this bond will open up. So what we will have now? We will have something like this. We will have something like this. Now starting from this, there is a CH3. Then there is a carbon CH and the O has been opened up. Right? So we have O minus. Then there is a CH2 over here. The C has, this oxygen has pushed back. So C double bond O and H. Okay. So now we have something like this. We have something like this. Just give a small arrow. Just this. Something like this. So now the two molecules has joined together. That's what we call a condensation, right? Aldol condensation. So the condensation has taken place. Now, what is there? O minus is there. Okay, so O minus is there. Now we are using what? Dilute base. We are using as a reagent dilute. This dilute is there. NaOH or KOH, that is dilute. So water molecule will be there in the reaction medium. So what will happen in presence of a water molecule? In presence of water, the O minus that is there, that will take a proton from the water molecule. What will happen? HOH is there. So this proton will take up one hydrogen. This proton will take up one hydrogen. And OH will be eliminated. Now we have something like this. CH3, CH, OH, CH2, C double bond O, H. Clear? The mechanism is clear. The first step, what happens? First step, an acid-base reaction takes place where the base, that is the OH minus, takes up any of the alpha hydrogen, because alpha hydrogen are acidic in nature. CHO group is an electron withdrawing group, so thus it is taking the electron out of it, so hydrogens became acidic. So OH will take up one alpha hydrogen, which are most acidic. Then this carbon ion that is formed, these are resonance stabilized. So this O minus will, this CH2 minus will push back, and O minus will be formed. Then O minus will push back, and this will react with the unreacted acetaldehyde molecule, thus undergoing condensation reaction. At the end, the O minus will take a proton, will take H plus from the water that is present in the reaction medium, and OH will be eliminated. So what we are having, we are getting a, this is my functional group, this is my alpha carbon, this is my beta carbon. So beta hydroxy carbonyl compound. Okay. So this is a basic example of an aldol condensation. But sometimes the reaction does not stop over here. Let's say we are applying heat. We are applying heat to this. Then one more step will take place. Okay. If we are applying heat or in presence of alcohol, either heat or in presence of an alcohol, another reaction takes place, that is elimination reaction takes place. In presence of heat or alcohol, what happens is elimination reaction taking place. Particularly E1Cb reaction takes place, and what happens is the OH from this carbon, the OH group, and the one hydrogen from the alpha carbon, gets eliminated. Okay, so the water molecule basically get eliminated, and we get something like this. A double bond is formed, CH, C double bond O, H. Okay, so what we get is a, now see, this is my main functional group, this is my alpha carbon, this is my beta carbon. So what we have is alpha beta unsaturated carbonyl compound. So any one can be the product of aldol condensation, right? It can be a beta hydroxycarbonyl compound also, but it also can be an, if heat is given or alcohol is there, then another step will add up and an elimination reaction will take place, resulting in a formation of an alpha beta unsaturated carbonyl compound. Clear? So this is the basic mechanism of aldol condensation. Now over here what happened is both the initial reactant and the unreacted part, both are acetaldehyde molecule. So we call this as self aldol. We call it as self aldol because there is only one type of reactant, that is our acetaldehyde molecule. So therefore we call it what? Self aldol. Obviously now you can understand that if there is a self aldol is there, then there must be a cross aldol also, right? So we will study all the type of aldol. Just give it a time. Just look at the mechanism once, what happens. I am just telling you again, just repeating it. First step is an acid-base reaction in which OH extract the alpha hydrogen. We get a negative charge inert ion which undergoes resonance. So due to resonance, the reaction is favored because resonance stabilize an intermediate. This is basically an intermediate. So due to resonance, this negative charge gets stabilized. Therefore, the reaction proceeds enough. And then there is the O minus pushes back and CH2 attack to the carbon of the carbonyl compound. Right? Now this, then there is a condensation reaction taking place resulting in formation of O minus. Now any negative charge we know that is not stable, so it takes one hydrogen from the water molecule that is present in the reaction medium, so it becomes OH. So now we have a beta hydroxycarbonyl compound, right? The beta hydroxycarbonyl compound is there. The reaction may stop over here, but if there is a heat or alcohol that is present in the reaction medium, then another step takes place, that is elimination reaction, and we get OH and the acidic hydrogen gets eliminated and we get an alpha beta unsaturated carbonyl compound. So whenever in the reaction, whenever in the questions, you will see an aldehyde or a ketone, right? And with that you see OH minus, or in the product you see a beta hydroxycarbonyl compound or alpha beta unsaturated carbonyl compound. Always try to think of a aldol condensation, that this is a very good possibility. So again we will do another mechanism for self aldol, but this time we will start off with a ketone. This we have done with an aldehyde, now we will do it with a ketone. I hope you all have written the mechanism. Okay, now we will do with a basic ketone, that is acetone molecule. Now if you have already understood the mechanism, I will just encourage you to pause the video, try to find out the product with yourself and then check it by resuming the video. Or first try to do what, if you are also good with the mechanism also, then I will just ask you to see whether you can write the direct product or not. Because see, in the exam our main target is to solve, to reach the right answer, but also in a limited amount of time. So whatever time you can save, 30 second, 40 second per questions, that we have to snatch it. Okay, because that will help us solving one or two question extra. So if you're good with the mechanism, if you can predict the results, if you can do the if you can find out the full result or full product, then I will encourage you to do the same. Okay, but if you're just starting, then go step by step, do the mechanism, see whether you can find the correct product or not. Okay, so one step at a time. So the product, if we draw this, the product will be something like this: CH3, COH, CH3. This will be a product. Again, if heat is there, let's say heat or alcohol is there, it may lead to another product also. That will be CH3. Water and OH and H will be eliminated. So we get something like this: CH, C double bond O, CH3. Okay. Now those who are writing the product directly, just see whether you are getting one of these two products or not. Okay. This is basically again, this is my main functional group, that is the ketone. This is my alpha carbon. This is my beta carbon. So this is beta hydroxy carbonyl compound. And this one again, this is my alpha carbon, this is my beta carbon, this is my alpha beta unsaturated. Unsaturation means a double bond. Okay. Double bond or triple bond, therefore we call it unsaturated part. Over here double bond is forming, so alpha beta unsaturated carbonyl compound. What will be the reagent? Reagent is basically OH minus dilute. This can be heat or alcohol. Okay. So now those who have directly done it, see whether you are getting the product. Those who are going by the mechanism, now let's do the mechanism step by step. First we have acetone molecule. Okay. So now see both the carbon that are in two sides of this carbonyl group, C double bond O group, are alpha hydrogen. So we have 6 alpha hydrogen. So in presence of an OH minus, take any of the hydrogen. In presence of a dilute OH minus, we will do acid base reaction to any of the hydrogen. Let's say I am taking the first one out, CH2 minus I am doing, followed by C double bond O, CH3, right? This will push back over here, this O will open up. So again, show the resonance. Right? This is my resonance stabilized intermediate. Now again we have unreacted ketone over here, that is acetone over here. This will push back. This will push back. This will open up. So something like this will take place. And we will have something like this. CH3. This carbon is there. Again we have a CH3. O open up. So O minus. Then O is attacking the CH2. O has pushed back. So C double bond O. CH3. Right. Now in presence of water. Now there will be water. We will have CH3. CH3. This O will just turn up to OH. Then CH2. C double bond O. CH3. Now check this one and this one. Both the products are same. This product that we have created and this one, both are same, beta hydroxycarbonyl compound, right? So this is my product. Now if there is heat given or if heat is supplied, then an elimination reaction will take place. And we will have CH3, CH3 double bond. One of the hydrogen from the alpha carbon, this one of the hydrogen from this one, and this OH will be eliminated. So the product will be CH, C double bond O, CH3 in presence of a heat, let's say. Okay. So these are my two products. Anyone can be the product depending on whether heat or alcohol is given or not. So This again we are using ketone, but same type of ketone, right? So same type of ketone is there. First step will be my acid-base reaction where a resonance stabilization will be formed. Then there will be a nucleophilic attack, and then we have O minus, and then elimination finally, and we will get product. Clear? I hope the mechanism is clear. Now let's say we don't have same type of molecule, right? So this is also an example of a self-aldol, okay? So this is again an example of a self-aldol. Clear? So now let's say we don't have same type of molecule. So now we will move on to something called cross-aldol reaction. Now we will undergo something like cross-aldol reaction. Over here you can finally predict that it's not taking the same molecule. Okay. Let's say we are doing a cross-aldol between CH3, C double bond O, H, CH3, C double bond O, CH3. So we have acetaldehyde molecule and we have acetone molecule. Okay. So if we are doing the reaction over here, first things first, OH minus. What will be the products form? Okay. So this might be a question. So what will be the products form? So the first step, OH minus C. Now we have to find out the alpha hydrogen. Both the molecules have alpha hydrogen, right? Both the molecules have alpha hydrogen. So first there can be a self-aldol also. So if there is a lot of molecules are there in the reaction medium, let's say this molecule will undergo a self reaction and we will form a product which we have formed already. This will be the product, first product, that is the self-aldol product of this two molecule, right? Again, this one can also undergo self-aldol and will form a product like this. So these are my self-aldol products that will be formed. The mechanism of how they take place we have already discussed previously. Now, along with the self-aldol product, what we will get? We will get a cross-aldol product also. Let's say CH3C double bond O, H is there, and OH minus came in and abstract a hydrogen from this. Sorry, that will be CH2. Right? This will take place resonance, undergoes resonance, and we will have something like this. Right? Now, instead of doing reacting with the same acetaldehyde molecule, now it will react with the acetone, right? So now we will have an acetone molecule. This will attack over here. This will push back and attack this carbon. Okay. Now what we'll have? We will have a condensation product in which CH3, CCH3, O minus, CH2, C double bond O, H is there. Again, if H2O is there, what will happen? It will take one proton from H2O. So we will have something like this: CH3, COH, CH3, CH2, C double bond O, and hydrogen. So this is one of the product. This is my product number 3. Let's say this is my product 1. This is my product 1. This is my product 2. This is my product 3. In the similar sense, what will happen? The acetone can also undergo the first reaction. So let's do that also. Now CH3, C double bond O and CH3 is there, and OH comes to attack. OH minus will take place and one of the alpha hydrogen will be eliminated. Now again the same thing, resonance stabilization will take place, and then we'll have something like this. Now instead of attacking a acetone molecule, there will be acetaldehyde molecule. So condensation reaction taking place. So we have CH3, C O minus, CH2, C double bond O, CH3. Again there is a water molecules over there. So in presence of water it will take a proton, and we will have CH3, CH, OH, CH2, C double bond O, CH3. So this is my basically a product number 4. Clear? So I can write it that I could write that product 1 and product 2 that are formed, these are self aldol product. Product 3 and product 4, these are cross aldol product. Right? This product number 3 over here and product number 4 over here, the mechanism that we have done, these are cross aldol products. Right? So what is there now? We have done the mechanism. Okay, the mechanism you will understand by practicing by 2 to 3 times, but there are some nitty-gritties or some basic concepts that are very important, that will be very useful for the examination. So the first thing is, from the very starting of the example, let's say we have seen one thing. If you have noticed, then it's very good. Okay, see the aldehyde or the ketone in which the OH attacks, I'm telling you again, listen. The aldehyde or the ketone in which the OH attacks first retain the C double bond O character or the carbonyl character. Over here, see, in the cross aldol you will understand this better. At the first example, what happened was the first reaction takes place in the acetaldehyde molecule. The OH minus initially attacked the acetaldehyde molecule, and after the reaction, after all the things are done, which functional group prevailed? That is the aldehyde group prevailed. Okay, at the terminal product, which functional groups retained? It is the aldehyde that is there. Okay, this is very important because when, let's say, you are given a product and you are asked to find a reactant, this small concept will come into a very important role. The group, in particularly in cross aldol, the group which is attacked first by the OH, that functional group is retained. Over here, OH first attacked the ketonic group. Okay, the OH first attacked the ketonic group, and aldehyde was attacked second in the latter part. So what group that is retained? The group that is retained is a ketone. So this is the first thing that you have to understand. Okay, this is the first thing that you have to understand. One, done. Next thing, you might think, when there are a number of product or when there are two cross aldol product, the question comes, which one will be major, which one will be minor. Okay, now see, the first step is the acid base reaction. First step is the acid base reaction. Nothing to do with the mm, steric effect of the reaction. But the second step, now the second step is the step in which a backside attack takes place. In this step, where I am marking with the red one, over here a backside attack takes place. Backside attack is happening. Okay, you can see again in this one a backside attack is taking place. Now the one which is less sterically hindered, that will favor the reaction. Simple logic. Over here the backside attack is taking place on a ketone. This molecule is a ketone. So the backside attack is taking place on a ketone. Whereas in this one, the backside attack is taking place on an aldehyde. So who do you think has more reactivity? In the carbonyl chapter, we say that the reactivity lies in the sequence. The reactivity lies in the sequence if there is a formaldehyde molecule, if HCHO is there, it has the highest amount of reactivity because there were two small hydrogens. It has the highest reactivity, followed by aldehydes and then followed by ketone. So over here, the backside attack is taking place on a ketone which is sterically more congested. There are two big methyl groups are there. The two big methyl groups are there which may hinder the reaction, but in this side there is one hydrogen which is very small in size. One side there is methyl group, but one side there is a very small hydrogen. So between product 3 and product 4, if we are comparing, then product 4 is more favored because of the simple reason of the steric hindrance of the aldehydic and ketonic group. So clear about this one? The first thing we have to understand is which functional group will be retained, the aldehyde or the ketone. In this, the answer is the group in which the OH attacked first. Done. Now the understand which reaction is more favored, in which the backside attack is reacting a less hindered functional group. If the attack is taking place on the aldehyde, obviously it will be more favored as compared to a ketone. If there are two ketones, then we will see whether it's both CH3, CH3, or one is CH3 and another one is C2H5. Then based on the size of the uh, groups, we can understand the reactivity or the favor of the reaction. Okay. So this is how, these are the small things that you have to understand while doing the reaction. Reaction is not at all a memorizing part. You have to know where the reaction will take place, and reaction always undergo particular sequence. It is not something haphazard. It always follows some pattern. It always have some logic. It does not, it's nothing random over here. It always follows a logic. Whether it's aldehyde ketone, then we will see the reactivity. ACHO has the highest reactivity. That are the thing that you should, these are the basic concept that will be used to understand the reaction. Now then, see, one might have another question, that why? Let's say I am taking an example of this one, CH3 C double bond O H. And in the first step, what we have done is OH minus is taking an acid base reaction and doing CH2 C double bond OH. Right? You may think that why the OH minus will do an acid base reaction. OH minus can simply undergo a nucleophilic attack, something like this. And CH3 CHO minus and OH minus may be formed. Now see why the second part, the second mechanism is not taking place. Or if it is taking place, it will be in very minute amount, negligible minor product, we don't consider this. Because see, this intermediate is stabilized. This intermediate is stabilized by resonance. It is stabilized by a resonance, and resonance is a very good stabilizing factor, right? This intermediate is stabilized by resonance. So therefore the first one is more favored. What will be the future of this one? Why the reaction will take place? In presence of H2O, maybe in presence of H2O, we will have something like this, CHOH, CHOH, H, let's say. This is 2OH diol. Diols are in again unstable. Again unstable, it breaks down to give out water, and again we will have CH3, C double bond O and H. So we are getting back the reactant only. So therefore this mechanism is not favored. This, the formation, the first step, nucleophilic substitution reaction is not favored because nothing is coming out of it. We are again getting back to the reactant only, right? But the first step, a new product is being formed. There is a future of the reaction. So that's why this mechanism is followed, not the second one. Clear? Again, then the second doubt that might come in the second step, CH3, again CHOH, the step 1 we have discussed. So CH2 minus is there and C double bond O H, which is undergoing resonance, and we have CH2 C O minus H. Now what we are doing? We have CH3 C double bond O H. Now what we are doing? We are pushing back this one. The carbon is attacking this, or the double bond is attacking this one. If you're doing the arrow, then basically we do it something like this. This will attack this carbon. Now one might think, then why push back? And we are forming a product something like this, right? CH3 CO minus CHO minus CH2 C double bond OH. we're forming something like this. Now, one might think that instead of following this kind of mechanism, what we can do is the O minus can directly attack. The O minus can directly attack this, and we could have product something like this: CH2 CO CO minus CH. This could be another possibility, right? Now understand this. First of all, if we are following this mechanism where I'm drawing it with another pen, if we are following the mechanism with green, the mechanism that we have shown, what are the things that are forming? First, we have to see this. When the condensation takes place, a carbon-carbon bond is formed. A carbon-carbon bond is formed. Okay, this is stable. A carbon-carbon bond is more stable than a carbon-oxygen single bond. Always remember, carbon-carbon bond is more single bond is more stable than a carbon-oxygen bond. And carbon-oxygen double bond is more stable. Over here, we are breaking the carbon-oxygen double bond. But in the orange one, we are breaking the carbon-oxygen double bond. No carbon-oxygen double bond is formed. Over here, a carbon-oxygen double bond is formed, right? So therefore, due to these two reasons, what happens is this CC bond, which is the main predominating factor, carbon-carbon bond is formed. So therefore, the green mechanism is followed, not the brown orange ones, right? A carbon will always try to associate with a carbon. Clear? So these are the reasons why this mechanism is followed. First step clear, why there is substitution reaction not taking place for and acid base reaction is taking place because in a substitution reaction there is no future. This molecule, this intermediate has no future. This will again break down to form this one. That is the reactant of the molecule. Therefore, the reaction will not move in this line. Now, if I told you to study something or to do something that has no future, why will you do it? Right? We, the molecules, think of a molecule like a human. It also have the ability to think. So it will move on to that part only which has something new to offer. Okay. It has something that is something new, something that is more stable, something that is less stable, but something new. So if, for the first time, if the substitution reaction takes place, there is no future. Instead of acid-base reaction, there is a future. A new compound is being formed, right? So this is basically this is the basic of aldol condensation, the self aldol as well as the cross aldol. Okay, self aldol always takes place when there is a reaction between two compounds. Self aldol will always take place along with cross aldol, right? And between the cross aldol, we can find out which one is a major product, which one is a minor product based on the reactivity of the substitution reaction, right? If the substitution reaction is taking place on a less crowded carbonyl compound, whether the reaction, if we are comparing between an aldehyde or a ketone, always it will be always aldehyde that will favor the reaction compared to ketone. If we are comparing between the two ketone, then we have to see the side group. The side group which is more bulkier will show less reaction because of steric hindrance. So these are the things that we have to know. First things first, if we wrap up of what we have studied till now and we try to wrap up the aldol condensation, then the first point that we have to know that which compounds undergo reaction, that are the carbonyl compounds. Okay, now what kind of carbonyl compounds? The carbonyl compound that have an alpha hydrogen. Clear? It is very clear from the mechanism why alpha hydrogen is required, because the first step itself requires an acid base reaction where hydrogen is takes place from taken out from the alpha carbon. So if a molecule does not have alpha hydrogen in the first step, the first step will not be completed. Very simple. If the first step is not completed, then how can we move on to the second step and do all the things that are nucleophilic substitution reaction and then water molecule? Nothing will take place if the first step is not there, right? Let's say you're going to school or going to the tuition. Now, if you don't leave your house, you go to the tuition, let's say you study 3 subject, 4 subject, you do the homework, you came around and do whatever you want, your days move on. But if you don't leave your house, if the first thing is there that somebody put a lock on your house and you can't leave the house in the morning, then nothing will take place. So that is the main thing with the alpha hydrogen also. If there is no alpha hydrogen present, the first step instead itself gets sabotaged. And when the first step is sabotaged, nothing will take place. Okay. So carbonyl compound, of course, it will take place in the carbonyl compound that have an alpha hydrogen. What are the reagents that are taking place? The reagent that we require is a source of dilute OH minus, that can be KOH, NaOH. Okay, so this is the reagent. We get a condensed product. Condensed product can be a beta hydroxy carbonyl compound, or it can be alpha beta unsaturated carbonyl compound also. Done. Then we have done the mechanism, we have found out. Then we will move on to the when there can be two types of aldol, that is when there are two compounds present, two different carbonyl compounds. So we will have a self aldol product plus cross aldol product. And when we are comparing with the cross aldol product, then we have to find out the reactivity. We have to see the reactivity. The one which is more reactive, if the substitution reaction takes place on that, then we will have a major product. Okay. Now remember, it is talking about the second step. Okay, we are talking the reactivity in the second step, not the acid base step, not the first step. The second step, where the backside attack takes place from the carbon atom to the another carbon atom. This step we are talking about. This step we are considering the steric hindrance. Okay, so basically we are talking about this step, not the first step. Steric hindrance should be considered when we are doing this step, the second one. So based on this, you can easily find out which could be a major product, which could be a minor product. Okay, so these are the basic things of aldol condensation. Then we will move on to the next part, that is aldol condensation. Now instead of a base in acidic medium, that is also possible. Okay, so the thing is, now we will do something called aldol condensation, that is also possible in the acidic medium. So yeah, now the aldol condensation in acidic medium. Now initially what the aldol condensation that we have studied, that is the main aldol condensation that takes place in the presence of a base that can be dilute NaOH or dilute KOH, right? But the possibility of an aldol condensation in an acidic medium is also there. But let me tell you this, over the past year question, if you see that you will find out that the majority of the questions will come from the aldol condensation in the basic medium that we have studied till now. But it's no harm to study the mechanism, because if the question comes, then you should be prepared. Okay, so basically it's in acidic medium. So as you can know, the basic difference will be over here an acid will be used. Let's say I'm taking an HA type of acid. HA is basically HCl or HBr, whatever you want. Okay, so CH3, C double bond O, H. So in the first step, what will happen? HA will be added, right? So what will happen over here? First step, hydrogen will get attached to one of the elements. Now we know that oxygen is the most electronegative over here. So CH3, C double bond O, H. Now oxygen is making 3 bonds, so there will be a plus sign, and this will be there. Now CH3, for my convenience and for your understanding, I am writing CH2 and H. Okay. So what happened is this HA bond got broken down. Now we have what? H got attached. So we have A minus, that is my conjugate base. Now A minus, that is the conjugate base. What will happen? It will abstract this hydrogen. So this will move over there and this bond will open up. So what we will have? We will have something like this: CH2 double bond C OH. What is called? This intermediate is basically called an enolate, right? There is an in and all, alcohol group and alkene. So enol intermediate, right? Now again there will be unreacted molecule over here. Unreacted molecule CH3, C double bond OH. These are the unreacted. Oxygen has a lone pair, so this will push up, this bond will attack this one, this carbon, and what we'll have? We have something like this. This will open up. So we have CH3, CH O minus, and then we have this one CH2, C double bond O, and H. And now you know that there are plenty of acids over here. There are plenty of acid. So this will end up something like this. Okay. This again, the products are same. It is also, now see, this is my main functional group. This is my alpha carbon. This is my beta carbon. So this is basically a beta hydroxy carbonyl compound, right? And in presence of excess acid, when the acid is in excess, then again an elimination reaction will take place, and what we will get again an alpha beta unsaturated carbonyl compound. So CH3 CH double bond CH, C double bond O H. Okay, so this is there. This is my alpha beta unsat carbonyl compound. right? So this is the mechanism. So the one thing that you have to understand is the mechanism is a bit different, but the products are same. In the normal aldol condensation, the OG aldol condensation, if we're talking about the original aldol condensation, the products are also beta hydroxycarbonyl compound and alpha beta unsaturated carbonyl compound. In the acidic medium also the products are the same, beta hydroxycarbonyl compound and alpha beta unsaturated carbonyl compound. Dep- the what is the difference over here? The difference is the mechanism. And another thing that the difference is there, if you want to know, it's for general information. In the last step, where the alpha beta unsaturated carbonyl compound is being formed in the original uh, uh, aldol condensation, this elimination is taking place, right? I am talking about the last step. This elimination is taking place. This elimination is undergoing the mechanism of E1Cb, elimination reaction via a conjugate base. E1Cb. What is E1Cb? If you don't know, then we will do a separate class depending on different where we will discuss different types of elimination. E2 is there, E1 is there, E1Cb is there, Hoffman bromamide degradation is there. So this elimination we will do. So over there, just we will discuss different type of elimination. So this is undergoing E1Cb, and in the acidic medium the elimination that takes place, that is basically undergoing E1, no Cb. It is um, under the mechanism of E1 elimination is taking place. But don't lose sleep over this. The question generally does not come from this. Generally the question will come from the mechanism part. Okay, so that is the thing. And also between the OH minus, the aldol in the basic medium and aldol in the acidic medium, the basic medium is by far more important, a lot time more important as compared to the acidic medium. Just for the sake of it, you have to know that the acidic medium aldol also takes place and the mechanism is something like this. Okay, now we will do something, a last part of this video, that is intramolecular aldol. Okay, this part is important because lot of questions comes. Intramolecular aldol. So you know that by the term, by the name of the term, you understood that something is taking place in the same molecule. Intra means in the same molecule. Inter means we are using two molecules, but intra basically means a same molecule. Aldol condensation taking place in the same molecule. Let's say we have a molecule something like this. Okay, this there were two aldehydic group at the two terminal position, 5 and 6, and over here we are adding O minus, sorry, OH minus. So understood this, both have aldehyde, both have alpha hydrogen, so an aldol condensation will take place. So what will be the product? Let's say this is something it is asked, what will be the product? Okay, so now just do it step by step. First we will draw the molecule. Sorry, we have a double bond O, this over here, there is no. So this carbon will have two hydrogen. These are alpha hydrogens. This is also an alpha hydrogen. So there are basically four alpha hydrogen, any of which OH can abstract. So in presence of alpha hydrogen, both are in the same environment. As you can see, both have the aldehydic group at the corner and there are no substituents. So both are in the same environment. So in presence of OH minus, any of the alpha hydrogen can be abstracted. So we will abstract one of the alpha hydrogen and then carry out with the reaction. Yeah. So in between the two alpha hydrogen, we will take one alpha hydrogen out and then proceed. Okay. So just continue with it. Let's say I'm taking this alpha hydrogen out. Randomly, I'm taking just a random thing. So we have this hydrogen and there is a minus charge over here. These two hydrogens are intact. So now again, now this will undergo resonance. It will come over here. This bond will move out. So we will have something like this. And again, the next step, this is the intermediate. My intermediate. This will push back over here. This will attack in this one, and this will open up. Now 1, 2, 3, 4, 5, 6. Whenever they have a ring system and then the reaction takes place, I will just ask you to number the carbons, okay? Because that will be very easier for you to form a product, right? It will be very easier, very convenient for you. So now see, we have how many ring? One, this carbon is getting attached. One, two, three, four, five. Five-member ring that is being followed. Okay, so basically we will draw a five-member ring. The first one is C2, then we have C3, then we have C4, then we have C5, and then we have C6. Now with this C2, there is a CHO group that is attached, right? So there is a CHO group that will be attached, C double bond O and H. Okay. With the C6, this O will open up. So we will have O minus and H, right? Clear? So this is also there. Now, again, in presence of H2O, what will happen? O minus will gain the proton. So sorry, we will have OH and we have a C double bond OH. Okay. So something like this, the product will be there, right? Now, what are the things that can be take place? Now you can see that this molecule, you can leave the reaction over here also, or you can do one thing also. The thing that you can do is, if the last step, the OH concentration is more, or if there is a heat, then there is a possibility of a double bond that will be formed. Okay. Now see, this carbon also has a hydrogen, this carbon also has a hydrogen, right? So which carbon will take place the elimination? Always we know that this is my alpha carbon, this is my beta carbon. So always an alpha beta unsaturated compound will be formed. So alpha beta unsaturated compound will be formed. So the double bond will come up over here. C double bond O H. Because see, the logics are very simple. If the double bond by chance comes over here, let's say this double bond is resonance stabilized. This double bond can undergo resonance. But if, let's say, I will use another pen and draw. Let's say if a double bond comes over here, C double bond OH, there is no faida in it. There is no benefit in it because this double bond is not stabilized by anything. There will be a double bond, but no stabilization will come. So the stabilization will always come when the double bond is in between the alpha and the beta position. Then the resonance stability is there, and stability in any form is a very important or predominant factor in organic chemistry. Sometimes there are different extent of stability. Let's say a resonance is a more dominating factor as compared to an inductive effect. Aromaticity is very dominating factor. So all of the molecule will under wants to move towards stability. Okay. Now see of the human also. You, why you are studying so much in the NCRT? If you see, there are basic self aldol and one example of cross aldol is there. Cross aldol does not even sometimes come in the exam also. Mostly self aldol comes. So why we are studying about different types of cell aldols, and then we are going to the intramolecular aldol, then we are going to the aldol in the acidic medium, and then we will solve different type of questions in which the complicated things are there where the mechanism has to be known in order to find the product. So why are you going in the detail? Because you want to go in some premier colleges, maybe for IITs or in the AIMS or IISc, ISER. So all the premium colleges you want to apply because you have an opinion, or everybody has an opinion, that premier colleges give you stability. You will get a good job, or you will start up, you will have your own startup, or you will be a professor in a big institute or in big colleges like Stanford, Ivy League colleges, something like this. Okay. So anyway, you are moving towards stability. So same way, organic molecules are very concerned about the stability. Where there is stability, they will always move to that position. They will not take the other way around where the things will be less stable or not stable. Okay. So always try to find out the stability and the electronic movement, where the electron is supposed to go, right? So if you have sorted out these two things, electron movement, whether it's electron donating group, electron withdrawing group, and the stability, your mechanisms will be a cakewalk. There will be nothing to remember. Everything is very logical. Okay, so there is a thing that goes on that organic chemistry is something to be memorized. Absolutely not. The mechanisms are given out by the scientists. By the scientists. These are not given out by random people. They have thought about it to a great extent. One reaction, for developing a reaction, for giving out the mechanisms, it took year. After that, this we will talk about Cannizzaro and Tishenko reaction. Tishenko reaction itself took 5 years to complete. Okay, so my point is, if you understood the basic, GOC becomes a very important topic because that brings out the foundation in this organic chemistry, and you have to apply those foundation over and over, foundation skills of the GOC, whether some stability is resonance, some stability is inductive effect, then you have to know that resonance is a greater factor than inductive effect. Or if some compound is getting aromatic stabilization, so always aromatic stabilization will be more as compared to resonance or as compared to inductive effect or hyperconjugation, whatever it is. So you have to know the basic concept, and you have to know how to apply the basic concept. And that's what the mechanism is important, because you won't be able to remember so much in the examination hall. Right? If you are going by the rote learning concept, you won't be able to remember this. But if you are going by the conceptual clarity, then everything is a cakewalk. Okay. So we will keep this video over here. Over here we have in detail completed aldol condensation, but it's not over. Okay. It's not over because we haven't done questions. So in the next video we will do, excuse me, in the next video we will do few questions that has came in the JEE mains and Neet and some JEE advanced. Okay, questions that will be done. So that will help you to apply, to understand how to apply those concepts. Only learning the concept is not enough. Okay, you have to know the questions, you have to apply those questions somewhere or the other, and then get the results. Okay, I thought I will complete it by today, but today the video already went a distance, so I will just advise you to just look at the video, just practice the mechanism, so that next day before I do the question, you can come up with the solutions. The questions are already mentioned over here. This will be first question, then followed by this. Try to do this. This one is a simple question. Why don't you take a screenshot of this? Take a screenshot of this question and try to solve this question. Okay, the first one, if you can solve this one, well and good. This is also a simple Aldol condensation question that came in 2022. So most of the questions that we will be doing will be recent questions after 2020. So you get a clear idea how the questions are coming, how to solve those questions. So I hope that you have learned a good deal of things today, and that's all.